Welcome. We want to start by letting you know that this exploration of material we've prepared for you today is generated by artificial intelligence. We'll maintain a professional tone and provide a comprehensive analysis aimed at a technical audience. Please know we intend to speak slowly and with deliberation. The material we're examining focuses on the principles of systems thinking, specifically how it applies within modern software engineering and, importantly, technical organizational structures. We're analyzing key excerpts from a significant resource on this subject. Our goal here is to extract the foundational concepts, the practices, and perhaps most crucially, the mental shifts needed. Shifts required to move from thinking purely about software components to really understanding and designing complex socio-technical systems. We plan to move through the source material structure quite methodically, offering a precise analysis of each part and chapter as we understand it.
That's a good plan. And the first part, titled A System of Thinking, really sets the stage. It defines the primary mission, as you mentioned, shifting perspective to gain what the source calls conceptual integrity. This idea, conceptual integrity, it's absolutely central. It means ensuring that all the abstract ideas, the components, the processes, that they all work together in harmony, supporting the system's overall goal. It's the anchor point.
Okay, conceptual integrity. And Chapter 1, what is systems thinking? Yeah, it seems to dive right into why this shift is necessary for professionals today. It talks about moving away from pure reductionism, breaking a whole into its parts towards a more systemic, nonlinear view.
Exactly. Reductionism or linear thinking is excellent for certain tasks, tasks that are predictable. Think about applying object-oriented programming principles cleanly or finding a single, isolated bug. That works well there. But, the source argues, modern software systems are fundamentally nonlinear. The system's own behavior changes the rules as it operates. Think about feedback loops, emergent behaviors.
So the system isn't static. Its operation changes the context.
Precisely. And systems thinking, therefore, isn't about replacing reductionism entirely. It's about expanding the technical tool set. It pushes knowledge workers away from maybe simplistic, dualistic choices, like seeing yourself as either an architect or a coder. Instead, the focus shifts to finding the right mental tool, the right perspective, to understand the complex situation you're actually facing.
That makes sense. So if conceptual integrity is the aim, Chapter 2 seems to imply it's achieved by focusing on the relationships between the parts, not just the software parts themselves in isolation, but how they interact.
Yeah.
Because the total effect, what the system produces together, that's what truly matters.
That's the core of it. And there's another critical dimension introduced. Time is always a factor. System states change non-linearly over time. Conceptual integrity isn't something you achieve once and then forget about. It's a quality that needs constant attention, constant maintenance, because those relationships are dynamic.
Which leads us to Chapter 3 and a really practical tool presented, the iceberg model. This seems designed to achieve lasting change by forcing us to look below the surface to find the root causes of systemic challenges.
It's a very powerful mental model. It guides your analysis beneath the visible events, things you see day to day, like, say, teams fighting over requirements or maybe a recurring production issue. Beneath those events, the model pushes you to identify recurring patterns. Is this conflict or this type of outage happening again and again? And those patterns, the model suggests, are reinforced by often invisible system structures. Think organizational silos, incentive systems, maybe even the way your code base is structured.
And the deepest layer, the most fundamental according to the source, is mental models. These are the deep-seated beliefs or values held within the organization, or even by individuals. Things like engineers shouldn't talk to customers, or failure is unacceptable. So using your example, fighting teams the event might reveal a pattern of poor cross-functional collaboration. But the root cause could be an organizational structure, like separate P&Ls, underpinned by a mental model that doesn't actually value collective learning or shared success. Addressing only the event, the fighting, won't fix it long term.
Exactly right. You have to get to the lower levels of the iceberg. And that's a perfect transition to part 2 of the material. You are a system of thinking. This part introduces a fundamental shift, perhaps more personal, but just as technical in its implications. The required awareness of one's own thinking. Metacognition, or self-awareness, is presented as the absolute foundation for doing effective systems work.
Why is self-awareness so foundational here? The source links it to handling ambiguity, doesn't it?
It does. Complex systems inherently involve ambiguity. There will always be multiple interpretations, often equally valid, of what's happening. Without self-awareness, without understanding your own biases and assumptions, that ambiguity can be paralyzing. You can't make clear decisions. Developing this self-awareness builds the capacity to navigate the uncertainty that is just part and parcel of large-scale architecture.
Chapter 4 implies that self-awareness is about discerning signal from noise in complex, often chaotic environments. That ability to discern, to see clearly through the complexity, is framed almost as a superpower for navigation. It requires actively observing how your own mind works, challenging your assumptions, questioning your initial conclusions, recognizing your cognitive biases. It's about understanding the how of your thinking, not just the what.
Which, as you pointed out, can feel less tangible for a technical audience sometimes. Chapter 5 tackles this by discussing the need to replace immediate reacting with considered responding. Often, we're blocked by emotional reactions, especially under pressure. These reactions are immediate, often defensive, but effective systemic analysis requires creating some cognitive space, a pause, to formulate a measured response based on the system, not just the trigger.
And this involves developing skills that might not seem technical at first glance. Empathy is highlighted, not just feeling sorry for someone, but empathy defined as truly understanding a situation from another person's internal frame of reference. How does this user, this support agent, this other developer experience the system you're building or changing? Grasping that helps design better socio-technical systems.
And the text suggests some practical, almost non-technical exercises to cultivate this space. Things like the 24-hour rule for potentially heated emails or conversations, or even just physical movement, getting up, walking around to intentionally manage cognitive load and break out of that reactive loop. Simple, but potentially quite effective.
It's about creating that pause. That makes sense. Chapter 6 then moves towards a system of learning. The objective isn't just acquiring information, but achieving generative learning. This is described as the continuous synthesis of knowledge and experience. This process is what builds wisdom, the ability to apply knowledge effectively, meaningfully, in the right direction for the system.
And the source provides a useful framework for thinking about knowledge flow, breaking it into 4 categories of activity. You can almost audit your team against these. First, generate artifacts. This is the obvious one. Coding, writing documentation, creating models. Second, observe and inquire, actively watching the system, asking questions, running experiments, listening. Third, synthesize. This involves bringing in external knowledge, reading, learning from others, connecting ideas. And fourth, experience critically, applying that knowledge to real-world problems, learning by doing. A system only generating artifacts without the other 3 isn't truly learning or building wisdom.
That's a very clear breakdown. So, generating code is necessary, but far from sufficient for systemic health. Okay, moving into the final section, part 3, systemic reasoning and patterns. This seems to focus on collective intelligence and making change happen. It emphasizes that reasoning together is the core mechanism for building that conceptual integrity we started with and for generating knowledge flow across an organization.
That's right. Chapter 7 formalizes this with the concept of collective systemic reasoning through creating a proposition. A proposition here isn't just an opinion or a random idea, it's defined quite rigorously. It consists of a clear premise, the core idea, which must be supported by, typically, 3 to 5 reliable, relevant, sound, and cogent reasons. And importantly, these reasons must explicitly connect the proposed idea back to the system's current purpose or goals.
So it forces a structured argument, linking the what to the why for the system. Makes sense. And doing this collectively ensures multiple perspectives are integrated, strengthening the idea's validity, especially when dealing with uncertainty.
Yes, and Chapter 8 implies that this requires intentionally designing feedback loops. These loops act as conceptual bridges between different groups or perspectives. The source details 4 core skills needed for strong feedback within these loops. First, proactive listening, really hearing, not just waiting to talk. Second, a genuine willingness to change one's own conclusion based on the reasoning presented. That's tough. Third, engaging directly with the reasons behind a proposition, not just the conclusion itself. And fourth, crucially, identifying logical fallacies. The text calls these bugs in the thinking code, which is a fantastic analogy for a technical audience.
I like that framing bugs in the thinking code. It makes fallacies seem less like academic points and more like actual defects in the decision-making process. Things like the strawman fallacy, misrepresenting someone's argument to attack it more easily, or the bandwagon effect, assuming something is right because many people believe it, or the slippery slope, arguing that a small step will inevitably lead to disaster without sufficient evidence. Recognizing these flaws is essential for productive technical discourse. If you can't debug the thinking, the outcome won't be reliable.
Absolutely. And these reasoning skills directly support the next concept, pattern thinking, covered in Chapter 9. Since systems behavior is often driven by recurring relationships and structures, the things lower down the iceberg model, we need to shift our focus. Instead of just reacting to individual events, like a single server crash, we need to intervene in the deep-seated patterns that cause those events. The goal is to find small, high-leverage changes that disrupt negative patterns or reinforce positive ones. Think adding automated linting to address recurring syntax debates, a small change addressing a pattern.
And effective pattern thinking requires analyzing different types of patterns simultaneously. The source mentions external patterns, shifts in the market, technology landscape, user behavior, then internal patterns, the software architecture itself, code quality trends, technical debt, and finally, process patterns, how teams work together, communication flows, decision-making processes, the organizational dynamics. Success lies in seeing how these intersect.
Precisely. And when you talk about understanding patterns and relationships, Chapter 10 implies that modeling systems becomes essential. But there's a key distinction made here. A model does not unify. Modeling does. The real value isn't the final diagram or document, although that can be useful. The true value lies in the process of modeling the conversations, the shared conceptualizing, the negotiation of understanding that happens when people try to represent the system together.
So the act of modeling builds the shared understanding. That's a powerful idea. And it helps structure these complex conversations and decisions. The source introduces a tool called the top-down elaboration, or TDE. This looks like a practical communication framework. It uses 6 specific sections: summary, WHY, WP, WHO, HRW, and when. Using this structure, say, for a new feature proposal or architectural change, forces clarity and alignment. It reduces the noise by making sure everyone agrees on the WHY before getting lost on the HOW. Linking these models or TDE documents together into a system of artifacts is also mentioned as key to maintaining that system's perspective.
Yes, it helps connect the dots across initiatives. This leads into Chapter 11 on systems leadership. Leadership here is redefined. It's less about command and control, which the source links to outdated industrial-age thinking. Instead, systems leadership is primarily about coordinating and supporting knowledge flow throughout the system or organization. The leader's role is described as integrative leadership, focusing on 3 main activities. First, curation, helping frame understanding, setting context, defining purpose. Second, systems design, actively working to improve the relationships and structures within the system, both technical and organizational. And third, orchestration, managing the timing and tempo of activities, ensuring things happen in a coordinated way.
And there's a challenging heuristic offered for leaders. What you know is probably your blocker. It suggests that a leader's past experiences and successes, while valuable, can sometimes prevent them from seeing the current system's needs clearly, especially in a non-linear changing environment.
It's a call for humility and continuous observation. Which brings us to the final chapter, Chapter 12, on redefining success. In complex systems, success isn't just hitting a specific linear target. It's measured by the system's overall health and its capacity to thrive adaptively within its environment over time.
So thriving implies resilience, adaptation, learning, not just short-term output. The chapter highlights 2 features of successful, thriving systems. First, they have enabling constraints. These aren't just any limits, but specific boundaries or rules that actually force observation, adaptation, and creativity. Think things like strict WIP limits in Kanban, or maybe budget constraints that drive innovation. Second, successful systems generate generative knowledge flow, meaning knowledge flows bottom up from the subsystems informing the whole. Learning happens everywhere. Ultimately, success in this view requires accepting uncertainty as inherent and consistently applying systemic reasoning principles. Well, that was quite a journey through this material. We've touched on the need for systemic reasoning over just reductionism, the critical role of conceptual integrity, the importance of self-awareness and managing our own thinking, tools like the iceberg model and TDE, and redefining leadership and success around knowledge flow and thriving.
It's certainly a rich set of ideas. The source material we've analyzed is dense, very practical, and clearly targeted at those building and leading complex systems. If these concepts resonate with the challenges you are currently facing in your work, we really do strongly recommend seeking out and reading the complete book, which is Learning Systems Thinking. The depth of detail, the examples, and the exercises provided there will undoubtedly strengthen your professional understanding and your ability to apply these ideas effectively.
Absolutely. And as a final thought for you to consider as you reflect on your own systems, If your organization, perhaps unintentionally, is primarily structured to reduce or eliminate uncertainty at all costs, how might you be accidentally destroying the very enabling constraints that could allow your teams and your systems to truly learn, adapt, and thrive? Something to ponder. We wish you a great day. We encourage all friends of the show to subscribe for more tailored analysis like this one. You can find links to relevant materials, including the book mentioned, and other resources in the description below. Thank you for joining us.